Hello, some of you may know me. For those of you who don't, I'm Matt Sauerhoff. I'm the Corporate Maintenance Supervisor for Quest Management Group. And today we're going to be making a video about troubleshooting the AC aspect of a split system HVAC unit. We're going to be focusing primarily on electrical problems and mechanical failure and troubleshooting using a multimeter. We have a unit here. Might not be able to see everything. We also have a bunch of components sitting out to make it easier for everyone to see. Okay, so we're going to get started. Best way to narrow things down when you're troubleshooting one of these systems is to know that they rely off three different types of voltage to operate. So they rely off 24 volt circuit, a 120 volt circuit, and a 240 volt circuit. So you save yourself a lot of time determining in which phase you're having your problem. And a lot of times it can be determined by just a visual inspection. So for a quick example right here, I have the breaker off to this unit. So we have no 240 volts going to it. On the other side, I did leave the breaker on for the furnace. So, just one of the quickest inspections you can do to narrow it down to what voltage your problem is on, and we're going to start by talking about the 240 volt components, is sometimes it's visual. You can see if that contactor, your AC contactor, is closed, and then you can also check the voltage on the side terminals. Look at the meter. You should get 24 volts. So anytime your contactor is going to be closed, you have your 24 volts across your contactor to your low voltage terminals, and nothing is operating inside this unit, you know that quickly that you have a 240 volt problem. Another visual inspection you can do, if you come up to the unit and you can hear the compressor running and the fan is not running, it's a 240 volt problem. And vice versa. Fan's running, your compressor's not running, 240 volt problem. So one of the first, quickest, easiest steps, if you determine that, is to change out your capacitor. Oh, you got it. All right, so your capacitor is located somewhere inside of the service panel. Typically it's bolted to the case right here. Like I said, you always want to make sure your power's off before you mess with any of this stuff. Typically there's some meters you can test the capacitor with. Always thought that was a waste of time. These things are cheap. It takes about 5 minutes, not even 5 minutes, to put one in. They cost between $12 and $15. And if you guess wrong and your fan motor is bad, and or your compressor is bad, and you wind up having to replace either one, you should always replace the capacitor anyway. So if something's not operational, it's always a good rule of thumb to just start with replacing the capacitor. And a lot of times you can look at these visual inspection and you can tell if they're bad. So here's a capacitor here. You'll see a burnt white spot. Anytime you see that, this thing's fried. Most of the time, the top will bubble out. So if you see it and it's convex like this, it's bad, change it. A lot of times you'll get lucky and then your fan will come on, or your compressor. A lot of times that was the problem. All right. Okay, so we talked about changing the capacitor. So you changed your capacitor already, and you have your 240 volts going across your contactor, and your wire connections, your spade connectors are all intact, and your fan still isn't running. You got a bad fan motor. You're gonna have to change it out. But real quick, I'll show you a contactor here that's added out of the unit. So you you want to test your line side, which is your power coming in, for 240, and then make sure you got 240 on the other side, because sometimes even though this is pulled in, this device can be bad itself. So that with those few easy inspections, you can tell if you have a bad motor or not. Changing out a fan motor, it's pretty simple. You just got to run your wires through the casing. There's 4 bolts on top. The most difficult part is getting the blade off of the motor shaft. So I recommend anytime you're replacing an outdoor fan motor that you also purchase the fan hub and blade with it. These things, they sit outside, they're full of rust, and I've seen it take longer to just get the old blade off than to actually replace the motor itself. All right, and the last test I'm going to show you that you can perform on a compressor to tell if it's failed or beginning to fail is to test the windings. This particular compressor we just replaced today, and unfortunately all 3 of them are burnt out, so we're not going to get an accurate reading, but you can still take something from it. So what you want to do is set your meter to ohms at the highest setting, and you want to start at your common pin, your common winding, and then you want to go to your run. That should give you the lowest ohm reading. The next highest ohm reading should be your common to start. And then finally, your highest ohm reading should be run to start. Now, at the same time, just to use simple math, if my lowest reading, which should be common to run, happens to be 5 ohms, and then my middle reading, common to start, happens to be 10, then your run to start should be 15. Now it's covered. Every component that utilizes 240 volts in your HVAC system, except 2. And it's pretty simple. One of the first checks, if you don't have power to your outside contactor on your line side, the next thing you want to check is your disconnect box. There's not one here. They're usually mounted on the brick. Some of them, sometimes you can find a wire burnt off in them, disconnected. Some of them have fuses in them as well. We don't have any here at this property to do, but I've seen it a lot of times. The fuses can burn out. They look like a battery, a black battery with 2 copper tips, and they're usually in your pull, mounted in the pull and the disconnect box. So you want to check them as well. Just check them, continuity on each side. If you don't have continuity through it, the fuse is bad. That's another reason you wouldn't get voltage to your outdoor unit. And then last is your circuit breaker. And this is a circuit breaker pulled out of the panel. Your outdoor condenser is always going to be on a double pole breaker. If this happens to be a 20 amp, it's usually going to be on a 30 amp. And all you would do is test both your output wires for 240. And if you're only getting half, or you're not getting anything and your breaker's on, replace your breaker. Okay, so we spent the first segment of the video talking about troubleshooting all the 240 volt components to the air conditioning system. So we're going to move inside now, and we're going to talk about 120 volt problems that could cause your system not to operate. In the beginning of the last segment, I talked about checking the contactor and seeing if you had 24 volts across the contactor. So let's assume that when we were outside, we did not. So this is going to sound weird, but it's all going to make sense in the end. Just because you don't have 24 volts to your contactor doesn't necessarily mean you have a 24 volt problem. It could still be a 120 volt problem. And real quick, I'm going to go over some of the components that are involved in your 120 volt circuit. And you're going to have your circuit board, your transformer, your fan run capacitor, and your fan motor, or your indoor blower. Let me cut it there. All right, just for this is solely for training purposes, so this unit is not energized at the moment. There also is a door switch that allows everything to be energized, but for training purposes, we're going to leave that off. That's one other thing, a simple visual check that would cause something not to operate correctly, is if this door's off. I mean, nothing's going to work. And we're going to talk about why. Okay, so how the furnace generates the 24 volts is you have a line coming in. The first thing it hits is the door switch. If the door switch is open, nothing's going to work. If the door switch is closed, everything should work. All right, so that's pretty simple. The next thing we're going to talk about is your transformer. What your transformer does, it has an input of 120 volts and an output of 24 volts. So everything that runs off 24 volts is supplied by the output of your transformer. So one of the easiest ways to check your transformer is set your meter to volts, and you want to test your output. It should, most transformers, it should be labeled which side is 24 and which side is 120 volts. If you do not have 24 volts coming out of your transformer, the next thing you need to check is to make sure it's being supplied from the circuit board. So your feed voltage for the furnace is going into the board first, and then it's coming out of a terminal typically labeled, can you see that? XMRF. So to test to see if you're getting your proper voltage, your 120 to your transformer, I would disconnect the transformer wires, power up the furnace, one lead on any neutral or known ground, and the other lead. So to test to make sure you're getting proper voltage to your transformer, the supply on the 120 side, you want to disconnect your two transformer wires from your board right here, and you're going to check on your circuit board, one lead to any one of these neutrals or a known ground, and the other lead to your XFMR terminal. Sometimes they're labeled primary 1, primary 2, depending on what model furnace you're working on. Always rely on your wiring diagram to make sure you're testing the right pins. So with everything energized, if you have 120 volts coming out of your circuit board to your transformer, and you do not have 24 volts coming from the output of the transformer, your transformer is bad. So that's one possible 120 volt problem. Okay, so we've performed the tests. One lead to a neutral or a known ground, your other lead to your output, your 120 volt output to your transformer. And like we said earlier, if you have if 120 volts is coming out of this board to the transformer and you're not getting 24 out of the transformer itself, the transformer is bad. Now, if it's the other way around, everything's energized and powered up, and you perform this test and you're not getting 120 volts out of the circuit board, then your circuit board is bad. And so you would want to change that out. Just like we talked about earlier, another component is your indoor blower motor, which also has a capacitor, just like the outdoor fan, except it's not a dual capacitor. It just supplies the fan. We'll show you one out of the case in a second. Okay, so we were talking about a capacitor. Just like the outdoor unit, the indoor fan is going to have one as well. It's a lot smaller. But before you replace this, there's one other check to do if your indoor blower is not operational. And there's two ways you can do it. One's a little fast shortcut. The other way, you can test on the board if you only have a multimeter. So, assuming that your door switch is depressed, assuming that we have 120 volts to the furnace and everything is energized, what you want to test for, you want to disconnect your black wire, that's your high speed wire, from the fan to the circuit board. And that wire should go to a terminal that says cool. And just like we tested before, you want to test to that cool terminal and to a neutral or any known ground. If you do not have 120 volts coming out of the board to the fan, then your circuit board's bad, and that's why your fan isn't operating. If you do have the 120 volts, the next thing I would personally do is try to change out your capacitor, and it only takes a minute. Like I said earlier, they're cheap, and if you're wrong and you got to replace the fan motor, you're going to have to replace the capacitor anyway. All right, you cut it there. Okay, so we've checked our circuit board. We're going to assume that we have power going out to the fan. We've replaced our capacitor, and we still don't have an operational fan. We're going to have to replace this blower motor. And I showed you earlier on the board how to check the output to the fan motor. An easier way, in case you're in this kind of situation where you got a ton of wires in the way, you can isolate your cool speed wire, non-contact voltage tester. We got power to the fan. Now, obviously our fan's running, but if it wasn't, we got power going to it, bad fan motor. These are a lot easier to replace than an outdoor unit. It's a lot less to take apart. Take the board off, transformer out of the way. There's two screws at the top, and the whole cage slides out as a unit. And in a second, we'll go show you what it looks like outside of the furnace. I can kill it. Okay, this is what the unit looks like pulled out. They don't come like this. You don't replace the entire cage and fan assembly. You only replace the motor. 3 bolts. You're going to flip it around. You're going to have a set pin. And they make a puller device that makes this easier, but typically if you lubricate this up well enough and have it unbolted from the other side, the weight of the motor will let it fall out very easily. Never strike this with a hammer. If you maim this shaft in any sort of way, it will not fit back through this hub, and then you're going to have to replace the whole housing and everything, which is a lot more expensive than a motor and a bit of a pain in the butt. And so never strike this with a piece of metal, a block of wood maybe. But you do not want to damage this or even scratch it on the sides, or you're going to have a hard time getting it out. All right. Okay, so we spent the first segment of the video talking about 240 volt problems. We spent the last segment of the video talking about 120 volt problems. And so now we're going to focus on the control system, or the 24, the low voltage. And I don't mean to get out of sequence, but we just discussed fan operation and what sort of 120 volt problems would cause the fan not to run, or how you could determine if the fan was bad. There actually is 124 volt problem which could cause your fan not to run. So if you have a bad board or a thermostat, the wires here, your green wire controls your fan, and your red wire is your power wire. So if you have an inoperable fan, in addition to everything I talked about in the last segment, next thing you want to do, if you can see, is take a little jumper wire and touch your red terminal to your green terminal. And if your fan then comes on, then your problem's with your circuit board, or possibly your thermostat, and we'll get into that more as we work through the 24 volt aspect. All right, the 24 volt system all starts at your transformer, like we talked about earlier. So if you've got a 24 volt problem, you're not getting your 24 volts outside of your contactor. First thing you want to check, just like we did earlier, is do you have power coming into your transformer, and do you have proper power coming out? We talked about what to do in the last segment if you do not have power going to your transformer. So let's assume that we do. And obviously, if you do have power coming in, no power coming out, no 24, you got a bad transformer. So moving ahead, let's assume that we do have power coming out of our transformer. It comes from these two wires, it enters the Molex plug and supplies the circuit board. So one quick way to know if your circuit board is bad, your LED light is powered by 24 volts. So no LED light, everything 120 checks out, you got a bad circuit board. The second way you want to check is you can go to your thermostat terminals. So one to your power wire, one to a known ground or a neutral. Down here you could be able to see it easier. A neutral, and your power wire, which is going to be your red wire. You should always have 24 there. The red wire is going to supply everything else that operates through your thermostat wire. Alright, so on your circuit board on the bottom here, you're going to have a Y terminal, yellow, W for white, red, R, green, G, and a C common. Typically it's going to be a blue or a black wire, but depending on what kind of wire they used, it could be any color. Yellow is going to your AC contactor. That's going to energize your AC contactor. White is going to energize your heating system. Red, like we said earlier, is the power wire that the board distributes to the different terminals and the thermostat. Green, your fan. And C is common. It's just another power wire. A lot of times this won't be in use. When it is in use, the purpose of it is if you have a thermostat that requires 24 volts to operate. For example, a thermostat that does not use batteries. So that's another check you want to do if you're not getting your 24. You want to see if you're getting 24 out of this common. If you happen to have that type of thermostat, it will not work if you don't get 24 volts coming out of this terminal. So just like everything else, you want to go to this terminal, to a neutral, or a known ground. And that's the same way you would test your fan. See if you were getting power to your contactor. can kill it. Alright, I'm going to talk a little bit more about using the jumper wire. Basically what you're doing when you're jumping from terminal to terminal is you're taking the thermostat out of the equation. So it's a real telltale sign to see if your thermostat's bad. I've seen a lot of people go to the thermostat and take it apart and tie wires together and jump it out at the thermostat. It's easier to just do it right here. So if you're not getting indoor fan operation, your contactor's not getting 24 volts outside, and you're suspecting that the thermostat could be the reason, it can all be troubleshooted right here on these terminals. So to test your contactor, you would go red, which is your power supply, to yellow. And if you go outside and your contactor closes and you got 24 volts to it, you know your thermostat's bad. Same thing with your fan operation. Red to green, your fan comes on, the thermostat's bad. Kill it there. Okay, so we're back outside and we're going to wrap up with talking about the last component in the 24 volt circuit. And ironically, that's the very first thing we talked about, your AC contactor. We talked about this first because it has 240 going through it, and it also has 24 going to each side. So after we perform all the checks we performed inside and everything turns out right, you come outside to this measure on your 24 volt terminals, and you have 24 volts. It'll be easier to see here. Come outside, you have 24 volts across, but this is not pulling in. You know your contactor's bad. A lot of times I've seen bugs get in here, debris, and prevent the circuit from closing. So I hope everybody learned something. I'll be available for questions after you watch the video, and I appreciate your attending the course. Have a good one.